All right. Hello, everyone. I'm Casper. I lead a design at a company called Snap Automotive. We do a lot of work with Android Automotive. It's actually my first time here at DroidCon, but last year, two of my colleagues were here, and they gave a presentation about Android Automotive in general and what can you do with it. So this year, I shared a little bit of what we have been doing in the last year. And since I'm a designer, it will be mostly from the design side, but I hope I can bring some context to what is happening in the car industry and how big of a deal Android Automotive is. So I want to start with this car. So it's a 1986 Buick Riviera, and aside from being quite ugly, it has one remarkable feature about it, which is that it's actually the first car to be fitted with a touchscreen. So you can see it here. It looks pretty cool, I think, maybe nicer than some of the cars today. So I just wanted to show that touchscreens are not something super new to the car industry. So since '86, car companies have been playing around with it. But of course, since Tesla came with the Model S, touchscreens have become like the default in the car industry. So today, we have cars like the new Mercedes that has their Hyperscreen, which has I don't know how many inches of touchscreen in it. So in this presentation, I just wanted to give an overview of like how did the car industry come to this point, and how can Android Automotive help to build better interfaces. So to do that, I have to give a little bit of theory behind how people interact with cars. And to begin with, I want to give like a rough grouping of the type of interactions that you can have inside a car. So there are basically three types of interactions you can have. The primary interactions, that's everything that happens that directly relates to driving. So think of reading the speed, checking the charge level, anything related to the ADAS, like the automated driving features. These are quite static, so you don't really have like interactions with them, you just read the information, and therefore they're often placed in the instrument cluster, so close to your line of sight. The second group of interactions, those are like fast and frequent, so they take a very short time to complete, and they happen very often. For example, changing the climate controls, like changing the temperature, changing the volume of the music, skipping a song. Those are secondary interactions. The third group is exactly the opposite. So these are interactions that don't happen very often, but they take a long time to accomplish. For example, adding a route, finding a charger on the way, opening a specific playlist in your media app. And let's have a look at these three groups and how they evolved over time. And I think a good way to do that is to look at the most like average car that you can buy, which is probably a Volkswagen Golf. So if you see here the third generation Volkswagen Golf, the primary interactions are very simple. It's like 4 dials and maybe some small LCD screens. These secondary interactions are 3 climate-controlled rotary knobs. And the tertiary interactions are really simple. It's like adding a new cassette in the player or adding a radio channel. Now, of course, changing the volume and changing a radio channel is there in like the third group, but it's probably a secondary interaction. But I want to show how these changed over time. So let's go forward a couple years in time. So this is the 5th generation Golf. And you can see that the primary interactions are quite the same. Maybe they have increased a little bit, so now you have a bigger LCD display, which shows stuff like your cruise control or some extra features that have come because of advancement. Same for the secondary interactions. So you have pretty much the same 3 dials, but some extra functions because over time cars become more modern and have more features. But there's like a really big change when it comes to the tertiary interactions. So you can see there's now a really big display. You have a bunch of different media options, like you can play CDs, a USB, or with a cable. You have a navigation system, you have extra settings. And so you can see that this third group of interactions has almost grown exponentially. This is not a touch screen, by the way. It's like indirect control, so you control it by the buttons on the side. And now I want to go to the Golf that is on sale today, and you can see that this trend continues. So you can see that the primary interactions, again, they have increased a little bit. So you can have a map now, but the essence is still the same as your driving-related information. These secondary interactions, also functionally speaking, relatively the same. Of course, you have extra stuff like seat heating and some extra climate controls, but they are largely the same. But again, the third group of interactions has grown exponentially up. Like, there's so much stuff in there now. I think if you see, there's like a companion app now and driver profiles. Volkswagen even put a shop inside the car. And like the biggest change you can see is that the second and third group are now in a touchscreen. So that's like a big change from other models. And so I want to go a little bit deeper into why. So why did they fit a touchscreen inside the car? Especially considering that they're not very well received generally. So both customers really don't like touchscreens, and researchers are not happy. Like, there's researchers saying that touchscreens are as distracting or even more distracting than driving while intoxicated. So it really leaves the question, like, why do car companies fit these touchscreens? So I want to go a little bit deeper into distraction, because that's the main feedback that is given to the use of touchscreens in cars. And I have to bring some nuance to this, because as I pointed out, over time, the number of features inside the car has increased exponentially. So especially this third group. If you think about how you would interact with technology in the 90s, you would have some CDs or some cassettes, and that's about it. But today we have Spotify, we listen to audiobooks, we have podcasts, and so even as simple as media now has a lot of different services, and we expect that to be inside the car. And obviously, car companies also fit extra stuff inside the car that we don't really need, but it's there. And so I want to bring some nuance to saying touchscreens distract, to actually saying we also have a lot more features inside the car, and those are distracting on their own. But let's say we want to design the interior of a car. Can we make it, considering that we want to have more features inside the car, can we design it in a way that it is not distracting, or at least less distracting than a touchscreen? So I want to go over a couple of alternatives and show what kind of choices you can make in that regard. First, let's bring some more context around distraction. People often think like, oh, looking away from the road, you're distracted. But there is more types of distraction than just looking away. So of course, looking away, that's visual distraction. But thinking about something else while driving, that can be cognitive distraction. You are not completely focused on driving. The third group is manual distraction. If I reach for my phone while driving, or if I reach for a control while driving, then I am distracting, then I have manual distraction. There is also a bunch of different consequences that come with distraction. Simple things like deviating inside your lane. You can have slower reaction time. You could have a much worse peripheral detection of objects or dangers. And also stuff like following distance is affected, and a lot more. So it's important to note also that not every type of distraction has the same consequence, and not every strength of distraction has the same consequence. So with that in mind, let's look at the kind of input types you can have inside the car and see how that affects distracted driving. So the first is touchscreens inside the car. So this is the Tesla Model 3. I think we've all known this interior. It's like almost touch only. Why would you pick a touchscreen in this case? So a touchscreen, as you can expect, it's different from a physical control, because while driving, you cannot use muscle memory to operate it. So you have to look to the screen and aim your finger at it. So that means you have high visual distraction and high manual distraction. But the cognitive distraction is relatively low to medium, because it's quite easy to look at the screen and point at what you want. And if making use of like common UI patterns, they're very similar to our phones and our tablets today. Then I've added a fourth point there, which is task completion time. It's an important measure to show how long you are distracted. And using touch, it's actually pretty short. So on average, completing a task is pretty short. Let's compare that to the second option, indirect input. A very famous system is BMW's iDrive. I think it's quite old now. It was debuted in the 7 series. First generations were pretty, but later on they got pretty good. So I have this BMW 1 series, and I'm pretty impressed with how it works. It's very rooted in reducing driver distraction and making sure you can operate it while driving. So it's actually pretty much the opposite of a touchscreen. So you have very low visual distraction. You can keep looking at the road and glance over to the screen. So the manual distraction is also less because you can basically, with muscle memory, play around with this controller without looking too much. But actually, the cognitive distraction is a little bit higher because it just takes much longer to complete a task. So think about filling in a route and choosing a route. It's quite a lot longer to do that with an indirect controller than with a touchscreen. And so you can already see the difficulty by car makers. Why would you choose one or the other? Do you choose for short task completion time but high visual distraction, or low visual distraction but a longer task completion time? It's very difficult to have an answer to that, right? So I think I can already see some people thinking, but what about voice, right? Because you can just speak to the car. And that's true. Voice input is like this kind of new, because with Google Assistant and other third parties entering the car industry, they're finally at a level that is good. So let's look at the voice interaction. So you have almost no visual distraction and almost no manual distraction. But it has actually surprisingly high cognitive distraction. You could have like 3 different groups of voice interaction inside the car. You can, for example, speak with a passenger. This has very low cognitive distraction. It's still distracting, but speaking to a person next to you is quite okay, because the person can see what's happening around you and adjust the conversation and pause when it's really busy. If you go one level higher in terms of distraction, you have having a phone conversation, because the person on the phone doesn't see what's happening around you, and so those usually score a lot higher. And then a voice assistant scores even higher than that, because it's even more difficult to speak to a voice assistant than to a person on the phone. So they have relatively high cognitive distraction. And there's 2 more things to note about voice input. It works only for like specific use cases. So selecting items in a list is almost like it's really difficult with voice. But for example, if you want to say navigate to Berlin, that's like perfect for voice, because with any other input method, that'd be super difficult. And the second side note is that error handling is extremely complex with voice. So if I say navigate to Berlin and the voice understands something else, the cognitive distraction goes through the roof, because I get annoyed, I don't know what's happening, and it's really quite difficult. So what I wanted to point out with this is that the ideal kind of input type in the car doesn't really exist. They're all quite distracting, and so you have to look at a case-by-case basis what is the best. So if you asked me, I think the best case is a mix of everything. It's a mix of touch, voice, and physical controls, where it is highly dependent on the design. So a really good designed, well-designed system scores a lot higher than a really badly designed system. And then as another side note, I do think that if you look at the different groups of interactions, like you have secondary interactions, the short and frequent ones, there isn't really a point in putting those in a touchscreen, because physically, like this is the Audi TT interior, is almost perfect the way this works. But I do think you can put them in a touchscreen if you design for the use of a touchscreen. So today, car companies put their physical controls and just place them in a touchscreen. and you have lots of buttons, that doesn't work. But if you rely a little bit on automation and other new technologies, you can make them work, and I'll show an example of that later. So I did mention it depends a lot on the design. And so this is a bit of an issue in the car industry because car companies really struggle when it comes to building good software. As an example, I had the really difficult job of testing this Porsche for a week. It's a fantastic car. It's crazy good build quality. It drives really well. It's also very expensive. But the software wasn't on the same level as the car. So I'll give two examples. So functionally speaking, there was a lot of things just not really well or missing inside the car. For example, finding a destination, it's just really difficult, like it cannot find its own museum. And then on the other side, design-wise, there's also some difficulties. Maybe there is a function that is there, but getting it working is quite difficult. So here's an example. Like one day I arrive at the hotel. The receptionist asked me, would you be able to charge the car only at night because it's just a lot cheaper for us? It's like, no worries. I enter the car and I tell it to charge only at night. But to do that, I opened the Charge app, and it was really complex. So you have to go into the Profiles tab, answer at least 3 or 4 questions about the minimum charge level and how you want to charge. Then you have to save this profile, go to the Timer tab, scroll through the settings, and make sure everything is set up correctly. And I actually had to look up a YouTube video, like a tutorial, on how to make sure my car charged at night. And I actually ended up just plugging it in right before I went to bed because I couldn't be bothered. Now, of course, it's very easy to complain about bad software in car companies, but since I've worked in the car industry for some time now, I have respect for the struggles that they have. Like, it's really, really complex to build a car. Just the number of engineering disciplines that have to come together to build such a complex product, it's really impressive. And so there's like hundreds of reasons why car companies struggle with software. And I just want to highlight 2. So on one hand, there is the functionality side, like I mentioned with finding searching a destination in a navigation system or planning a route or whatever. It's really lacking inside the car industry, and there's a couple of reasons. For example, today a lot of the cars run their own custom operating system based on some Linux version, and so there's really limited third-party integration. If you are a developer that has a good map, you will have to speak to every individual car maker to have your app inside the car, and so it doesn't really happen. The other part is the process. Developing software is quite different from anything else in the car industry. Designing and developing a car is just a waterfall model. And so mixing a waterfall model with like agile software development, super difficult. Now you may see where I'm going with this, which is Android Automotive. So just as a short recap, Google is quite confusing in their naming. So there's 2 things, Android Auto and Android Automotive. Android Auto, you may know, that's basically like Apple CarPlay. It runs on your phone, and it is mirrored on the screen inside the car. There's very little software from the car company that interacts with it. Android Automotive is what runs natively inside the car, and it's basically like having an Android tablet inside the car. If you are a car company, you can go 2 different ways. You can use Google Automotive Services, which means you get the Google Play Store, you get the Google Assistant, Google Maps, etc. But Google will be partly responsible for the design and therefore will give you restrictions on what you can do with the design and what app developers can do, and so they offer templates. You can also say, I don't want the Google contract, I'll just go without it, which means you have much more freedom, but you have to find your own app store and your own map service, etc., etc. Currently, there's 2 cars, well, there's a bit more, but 2 examples that have Android Automotive is Renault with the new Megane and the Polestar 2. They both used Google Automotive Services. So you can see that if we talk about the problem of functionality, if you use Android Automotive, you fix this in one go. So Android comes with like this standard software package that makes it very easy for app developers to build stuff on it. It helps a lot with development time, and et cetera, et cetera. So it makes sense that lots of car companies have already launched cars or have announced that they're switching to Android Automotive. And I am sure that if I give this presentation next year, there will be many more. So yeah, it turns out to be a really popular choice for the car industry. So that brings me to the second issue around software development. That's the process. So just because you use a sort of mobile development platform like Android doesn't mean you become an agile company. And so this is a lot more difficult to solve with car companies. And especially considering, like I mentioned, that distraction and just general comfort inside the car depends heavily on the design, it's important that car companies use a good process and build better software products. The great thing, though, is that now anyone can build automotive interfaces. Before, you couldn't because car companies use their own custom operating system. But now, anyone with some Android development experience can go out and play around with it. So that's exactly what we have done. We have started building our own sort of infotainment system. And the reason why is that we have been working with car companies for many years, and we've seen inside the struggles that they have. And we were waiting for a moment that we could do it ourselves. And the reason why is that our work process, now if you don't work in the car industry, if you work in the software industry, this is nothing new, right? We have developed this process on how to build products very quickly that create value. So the 3 parts is evidence-based design. So as any design or product decision, we base on evidence. So we have an idea, we have an assumption, we go out, we test it, we improve on it, go out and test it, improve on it, etc. So this is the second part, it's the rapid iterations. And the core part of this is designers and developers working very closely together. Now, in most software companies, this is nothing new, right? But in the car industry, the companies tend to struggle a little bit more with it. So we thought, okay, we are an independent software company. Let's see what happens if we start working with this process and what kind of products we can come up with. Do we really have to stick to the same designs that car companies use? Or do we come up with better ideas or ideas to interact better with the car? So 2 of these ideas that we have come up with so far, I just want to share quickly with them. So the first one is, what if, so a car is like a fixed product, and a car company thinks in terms of the car. Everything happens inside the car. Later on, they figure out, oh, it would be cool if we have an app that can connect with the car, and you have some functionality there. But the driving experience is more than just being inside the car. There's different contexts and different phases to interacting and driving the car. So why doesn't the software adjust to each type of context? For example, if you are driving, do you really need to change settings of the car? Or do you really need to install new apps? Probably not. Probably you just want to have some media, some navigation, and climate controls. But if you're in park, then you want to install new apps or watch videos or do something else. And if you are anything that isn't related to driving, why is that even inside the car? If you are inside the car, you are busy with driving from A to B. So anything like settings, personalization, etc., why don't we put that on a phone or an app? And you can do it outside of the car. Like this, we can not only give you the features at the right moment, but having a super simple interface inside the car helps with driver distraction, etc. So that's just one idea. The other idea is around automation. Like I mentioned, just putting physical controls on a touchscreen, that doesn't work. But the car knows so much about you, and it can use that to help you inside the car. Making a touchscreen less distracting means offering everything within 1 or 2 tabs. So an example of that is the climate controls. why do we still have to set so many different things to get the right temperature inside the car? You have to set temperature, the fan speed, turn on and on the air conditioning, set the wind direction, turn on seat heating. All I want is the car to be in the perfect temperature, right? So we have been playing with ideas. Why don't we just set the temperature and let the car figure it out? If the car is not correct, you can override it by saying, I'm hot, make me cool, or warm me up. So that's just one idea. But what is more important is how can we go and test if that actually works? And this is where Android has proven to be so helpful. For example, we have created an Android Automotive build that works on a tablet. So this is a Samsung, I think, S5 tablet. It's a couple years old, which means it's like the hardware of new cars, actually. And so we have Android Automotive that runs on it. So I have it here. You can see it here. It's a mock interface. But it's exactly Android Automotive, and it can do all the things that would normally fit inside the car. So as an example of how this helps us is that normally if you are in a car company and you want to test something, you have to build some prototype inside a real car and drive around with it. If you are an engineer and you want to see if your machine learning algorithm works, you have to somehow make the software run inside a car and drive around. But we can just take the tablet and stick it inside a car and drive around. Now, this is not only nice for developers, but for me as a designer, it's actually super cool. And I'll give you one example. Of course, I have been saying that secondary controls like volume, those would be perfect in a physical dial, right? But sometimes you work with car companies that really want to have everything in a touchscreen, and there are still ways to make this easier. So one idea I had is why, instead of using buttons that are very hard to press while driving, why can't we make a slider, right? You would aim for a certain portion on the screen, and moving your finger up and down sort of evens out all the movement inside the car. So building a prototype like this is really difficult as a designer. But all I have to do when we have this tablet is I can sit down with a developer, discuss my idea. The developer then, I think, uses Jetpack Compose, builds a super simple app, uploads it to our app store, and all I have to do is download it. So then, within 1 or 2 days, I have a prototype that I can play around with. So as a designer, this is so good because it is actually running in the native software inside our fake infotainment system. And so it looks really real to test participants. And for developers, it's great because Android Automotive is still relatively unknown. And so by just doing this prototype for 1 or 2 days, we have learned so much about limitations or other unknowns that we didn't know before. So in short, that's basically what we've been doing so far. Now in the coming months, we are going to start merging our prototype that's running in the design software onto our tablet and start playing around with actually testing this with users and seeing what comes out of it. And we're actually pretty excited about sharing this with everyone. So please do check out our blog and our website because we love to share what we're working on. Our build of the tablet is also available on GitHub, so you can download it and play around with it. That's it. Thank you all for listening. If there are any questions, I'm more than happy to answer them.